All right, so the last and final one, redox 3, electrochemistry, electrolysis. So we just looked at voltaic cells. That is a spontaneous. It happens on its own because one of them is more active than the other. All right, so with electrolysis, however, it is possible to use electrical energy to cause a non-spontaneous redox reaction to occur. The processes which are driven by an outside source of electrical energy are called electrolysis reactions, and it takes place in an electrolytic cell. So this one is electricity causing chemical reaction to occur, whereas the other one was chemical reactions causing electricity to occur. All right, so we've seen this before where there's the porous interchange. In this electrolytic cells, it has, again, 2 electrodes, but these are in a molten salt or solution. They're driven by a battery. There has to be a battery or some sort of direct electrical current. The battery acts as an electron pump, pushing electrons into one electrode, the cathode, and pulling them from the anode. I know it's the exact opposite. We'll get to that in a second. These electrodes are inert. Why? Because you're going from the cathode to an anode. You are doing the exact opposite. So instead of going from zinc to copper, you're going to push copper to go back to zinc. All right. So like this one, reduction still occurs at the cathode. Oxidation still occurs at the anode. Red cat anox. That doesn't change. You have sodium reducing at the cathode, though, and chlorine's oxidizing at the anode. So anox, oxidizing, chlorine is oxidizing, sodium is reducing, red cat, still the same. But instead of having the anode be negative, like anion, and cathode, like cation, being positive, the cathode now is negative and the anode is positive. Why? The cathode is now negative because the electrons are being pushed into it. The anode is positive because the electrons are being taken from it. Okay, so real quick exercise. For the electrolysis of molten magnesium chloride, write the half fraction that occurs. So you're going from Mg2 plus, it doesn't happen. So Mg2 plus to Mg, that means it's pluses to negative, 2 electrons. That is the cathode. It is reducing. We've got a negative to a regular, so it gains an electron. That's my anode. Anox, oxidizing, loses typically, but it is the reverse in a half reaction for electrolysis. All right. Electrolysis with active electrodes. Several practical applications of electrochemistry are based on active electrodes. For instance, electroplating. That involves using electrolysis to deposit a thin layer of metal on top of another in order to improve the beauty or the resistance of corrosion. So spoons and stuff like that. Electroplating. All right, looking at this, you have a battery. You have copper getting reduced and, object to be plated, a key, and then you're going to put copper. Copper is going to plate the key. So you're going from regular copper to this. The copper ions are turning back to a solid on this key. All right. Silver plating. That's another thing you might see. Again, you have the silver, which is really, really low on the activity table, table J. Object being plated. Whatever you want to silver plate. It gets pulled over. The anode goes from the solid to an ion. The ions then, on this one, turn into a solid again. They plate whatever it is, whatever that object is. Okay? So one thing to note, bleach. Why does bleach pull color away from your clothes if you accidentally splash it on it? That's because color is produced by moving electrons, right? Exciting the electrons. They get very, very excited, usually by heat. They pop up energy level from the second one, pops up, and then it falls back down. When it falls back down to the stable state at the second energy level, very good reminder, review, it gets excited, pops up to a higher energy level, falls back down to the second one. When bleach is poured or accidentally hits your clothes, it takes away, sorry about that, it takes away, it oxidizes, it removes those electrons, those excited electrons, which means they can't get excited anymore, which means they can't fall down to the second energy level, which means there's no more color. Okay? All right. So, yeah, we're going to talk a little bit about explosives like nitroglycerin. You do have oxidizing and you do have reduction. So what is oxidized? The carbon goes from, I would say, a +5 to +2, or sorry, a +4. So it at least loses 1. And then what reduces? Both oxygen and nitrogen reduce. So 4 moles of liquid go to 29 moles of gas in a rapid expansion, causing kerpudui, right? Okay. So the next thing I'd like you guys to do is work on the batteries, Poggle. This could help reinforce the voltaic batteries and a little bit of our electrolysis or the electro batteries, electrolytic batteries. If you guys have any questions, please don't hesitate to ask. Besides that, I hope you have a great day.